For this project, I'll be working with Kaggl's heart failure data set. So I'll be downloading it, and then back in my Azure workspace, I have to upload it. Yeah, I've already uploaded it successfully, so it's now a registered data set with the name heart failure. Firstly, I'll be training a model using automated ML. As you can see here, I have my packages that I'll be using to complete the project. Then I have my workspace and my experiment name, creating an experiment here. Next is my cluster, my computer cluster. Here you can see I have my CPU cluster with VM size standard D2V2. Next, I have my data set. I'll be claiming this data set using this code. So I'll be using the heart failure as my name so as to figure out if it's registered. And here it gives me an output as registered, so I can access my data sets. Next, I'll be going through my AutoML configuration. I have my AutoML settings. Of most interest is the primary metric here. I'll be using my AUC weighted. I find it most appropriate to use it in evaluating the performance of binary classification models. Here, I also have my AutoML configuration with a task as classification. And yes, as to predict the death events, so I have my label column name as death event. And so I'm just going to submit my experiment. So I'm going to wait till it's end. Here, if I go to my machine learning workspace, I'll find it also created in the AutoML section. Here you can see it has a status of running. So I'm just going to wait till it's complete. So you can see numbers of metrics being generated during the experiment run up until the 43rd iteration. Here it stops, and then I have it with the run details widget as completed. So my run is completed already. And also in the Azure Machine Learning workspace, also I have it also as completed. So my run is completed. And so now I'm just going to go ahead and print the best run ID. Yeah, I have it. So I have an AUC weighted score of 0.918, so 0.92 approximately. So next I'll be saving my best model. Yes, so I'll be going for model deployment next. Register my model. Then I'll be creating an environment. Next also is to create an inference configuration. Here you can see I also enabled application insights, that's login. So I'll be deploying the model, writing the code here. I'll be waiting for it to deploy it. Firstly, it shows running, and then I have it as succeeded. So it's completed already. So also in Azure ML Studio, I also have my deployment status here. So here you can see it. It's also showing succeeded. So that's it. So now in my endpoint section, I have a REST endpoint. It's a scoring URI. This scoring URI can also be found in my consume tab. Here, you can also see it here as a REST endpoint also here. So I'm just going to use this scoring URI or the REST endpoint to create a endpoint.py file. It's a Python script that I'll be using to text my model. So I'm just going to copy the endpoint, and in my endpoint.py file, I'm just going to paste it there. Here, as you can see, I have it as my scoring URI. Now I took two sets of data to score. So here you can see my endpoint.py file. So I'll be working with this to test my web service. So now in the Jupyter Notebook, I'll just run the endpoint.py file, and I'm going to send a request to test it, as you can see. So now it goes there. Then I find out the output. So I have the prediction values and the true values, as you can see. And also I have the logs. So the logs generated from the web service, here they are. It's pretty long. And then I just go ahead and delete the service and the cluster. Next is the hyperparameter tuning. I will still be working with the add failure data set. I register it already as add failure. And then I will just go straight to my notebook, import the packages that I'll be using for the experiment, as you can see here. I'm going to create a workspace and my experiment name as add failure hyperdrive model. And also working with the same complete cluster, I'll be using CPU cluster with VM size standard D2V2. Yes, so I have it as existing already. So I'm just going to work with it. And going further to the hyperdrive configuration, I'll be specifying a bandwidth policy with evaluation interval as 2 and slack factor as 0.2. And also my hyperparameters as this with the following ranges. So I'll be also working with a training script. That's my train.py. And my primary metric name is accuracy. So I'll be maximizing it. So I'm just going to run that. And on completion of the experiment, I got it to be completed. And I have my best model, my best model ID, best run ID. Yeah, I got an accuracy of 0.7833 with regularization strength of this. So I think the lower the regularization strength, the higher the accuracy. So printing out my best run ID and my accuracy, I have this. So I'll just go for and save the best model as hyperdrive model and then delete the cluster. Thank you.